All right, good morning, everybody. I hope everybody's having a fantastic day. I just finished watching The Tiger King last night, and if you haven't, whew, what a roller coaster of emotions. Okay, so today we're gonna be looking at applications of the Pythagorean theorem. Okay, so just to give you a heads up, the first lesson was introducing what the Pythagorean theorem was and what perfect squares were. Um, Second lesson was on approximating square roots, right? Approximating numbers using square roots, and then looking at irrational and rational numbers. And so today we're going to be looking at applications of the Pythagorean theorem, okay? Applications of the Pythagorean theorem. So we're going to do 3 examples, okay? And these are 3 real life examples that I've actually been part of, right? So you can sort of apply it to something if you'd like. But anywho, let's go ahead and get started. So just to remind you, what are some of the things that we're gonna need? We're gonna need the Pythagorean theorem, which states that if you have a right triangle, okay, a right triangle meaning that one of the angles is 90 degrees. If you have a right triangle, and this side is A, this side is B, and this side is C, then it is automatically true that if you take the short side, square it, and you add it to the other short side and square it, it's going to be equal to the long side squared. Okay? So, let's take a look at this example. Okay? I am standing right here. Okay, imagine this is the ground. We're gonna draw like a picture, okay? Imagine that's me. That's me, okay? And there is a redwood that's this tall. Okay? It's super tall. This redwood, I think redwoods grow to be like, 2,000 feet? Let's just say it's 2,000 feet tall. I could be wrong, okay? This redwood is 2,000 feet tall. And I am, 400 feet away. I want to know what the distance is. Let me use a different colored pen. I want to know what the distance is between myself and the redwood, the top of the redwood. Okay? Now, we're going to assume, right? We're going to assume that my eyes are down here, right? Because that's what the right triangle is supposed to look like. So we want to find this side right here, C. We want to find out what that length is. So let's write out the formula. First, always write out the formula, in my opinion. A squared plus B squared equals C squared. Okay? So, do we know what A is? It can either be 400 or 2,000. It doesn't matter. I'm going to just say 400. Square it. Plus B, which is 2,000, squared, is equal to C squared. Now, 400 times 400, that's easy. 4 times 4 is 16. And we have a total of 4 zeros. Same thing with 2,000. 2 times 2 is 4. And then we're going to have 6 zeros. And that's going to equal to C squared. This is actually 4 million, and that's 160,000. So 4 million plus 160,000 is 4,160,000, and that's equal to C squared. Now, a number times itself equals 4,160,000. So you're going to have to do the opposite or the inverse of raising something to the second power, which is rooting. So then C, the length, is going to be root 4,160,000. Now, if you have a calculator, please figure out what that is, because I don't have a calculator on me. But I can tell you this, it's going to be more than 2,000 feet, because 2,000 times 2,000 is 4 million, and this is 4,160,000. So it's going to be slightly more than 2,000 feet, okay? So whatever the heck that is, that's how long I would have to, or that's the length actually between the top of the tree and myself on the bottom. And I forgot to draw the little right triangle right there, the little 90-degree symbol. Let's take a look at another example, okay? We won't have to use such big numbers, okay? So, I used to work as a math lab tutor, and often I would get bored, okay? So suppose let me try to draw. That's a door, okay? This is a room. Imagine this is a room, okay? So, one day, I was sitting right here at the corner, right? My back up against the wall. This is a wall right here. Let me write that. Wall. That's a wall. So I'm sitting on the corner, right? Or on the edge of the wall. I'm super bored. And I have a buddy. There's a table right here, right? This is where the students would come and get math help. Let's just say that there's homework right here. And I was thinking, I want to throw a rubber band, but I want it to land right here. Okay? So, I mean, this kind of uses a little bit more than just a Pythagorean theorem, but the idea is still the same. Here's a ceiling, okay? So, I wanted to throw a rubber band up here so that when it hits the top, it just floats down that way. So, here I am on the ground, right? This is a distance to the table horizontally. Let me use a different color. This is a distance horizontally I needed to cover. This is the vertical distance I wanted to fall. I needed to figure out where to launch a rubber band, right? I just wanted to mess with my friend. Here's a little right angle. I'm shooting a rubber band up here so that it falls directly on his homework assignment. I knew that the room was 12 feet tall. And I knew that how far I was away from my buddy, it was about 9 feet. So I mean, I didn't really need to calculate. It was more like I just need to like hit the rubber band so that it lands right here. But I asked myself, what is the distance that it has to travel? And that's a perfect application of the Pythagorean theorem. I needed to figure out what C was. So A squared plus B squared equals C squared. 81. Sorry, I'm already thinking ahead. I'm not writing it out. 9 squared plus 12 squared is equal to C squared. 9 times 9 is 81. 12 times 12 is 144. That's equal to C squared. 81 plus 144. Well, 1 plus 4 is 5. 8 plus 14 is 22. And actually, we're going to take the root of both sides. C is actually equal to 15. 225 is a perfect square. So that means I had to shoot a rubber band 15 feet into the air so that it would land on my buddy's homework assignment and distract them from doing homework. I was doing this 6 years ago. Not that long ago. Actually, no, it was a while ago. I was going to say any questions, but I just realized we're not in class. Well, I mean, we kind of are. Not really. Kind of. So I'm not going to do the second assignment. I mean, the third example, because I have a strong urge to sneeze right now and start coughing. But for these types of problems, okay, you're going to be working with a triangle, okay? So draw the picture, okay? Draw the picture. Identify A, B, and C, right? So which one's your A, which one's your B, which one's your C? Remember, the longest side is always C. Identify and label the two known sides. So you're always going to know two sides, right? Because if you know two, you can find the third one. If you only know one of the sides, you don't have enough information to find the third side. And last but not least, once you've drawn the picture, you've identified what A, B, and C are, and you've labeled those sides on the picture, you're going to write the formula and use it, okay? Don't try to do everything at once, okay? Do it step by step. Read the problem first, right? Because these are going to be word problems. Read the problem. Try to visualize the problem. Once you visualize it, draw the triangle or draw the problem out, okay? Hopefully y'all are doing your homework.